2.5 standard deviations above the mean, and D, 1.5 standard deviations below the mean. All right, so this is what we're looking at here. Key things to understand. First one, the fact that it says normally distributed. All right, that's the first thing that you need to note. Normally distributed is telling us, once again, let's not forget, normal distribution tells us a bell curve. Bell curve tells us it's going to look like that. All right, so we start there. All right, we start there. All right, so that means we are going to have some kind of bell curve. And what we learned is that with our bell curve, we have our mean and we have standard. Remember, those are standard deviations. All right. So our mean is in the center. Our problem tells us mean is 100. So that is 100. Once again, that is our mean. Now, we go 3 standard deviations to the right, 3 standard deviations to the left. So we're going to need 1, 2, 3 marks. 1, 2, 3 marks. All right, so that's 1, 2, 3. 1, 2, 3. Next, tells us standard deviation is 20. Standard deviation is 20. So what we're going to do here is we're going to add 20. So now that's 120. To get our next one, we add 20. So that's 140. Next one, we add 20. That's 160. On the right side, we're adding, and on the left side, we're subtracting our standard deviation. So that's 80. Subtract again. That is 60. Subtract one more time, and that is 40. Okay, keeping in mind that this is 0 standard deviations. That's 1. That is 2. And that is 3 standard deviations, right? So let's look at it a few different ways. We call this our data value. All right, this one right here is -1. That one right there is -2. That one right there is -3. And these right here are our standard deviations. So now we can answer our questions, right? The first one is 1 above the mean. Standard deviation above the mean. Let me fix this. Doesn't really look like a 1. All right, once again, remember this is your mean. So 1 above it is this number, and this number pertains to that number. So this answer is 120. Okay. Part B. 3 standard deviations below the mean. I'm going to abbreviate standard deviation below the mean. Well, here's your mean. Below we go 1, 2, we go 3 standard deviations, which leads to this number, which is 40. So that's that answer. Okay, and part C, 2.5 standard deviations above the mean. 2.5 standard deviations above the mean. All right, so here's our mean. This is 1, this is 2, and this is 3. So 2.5 is somewhere in the middle there. And if we look at 2, it has 140. We look at 3, it has 160. So we're looking for the middle, right? So we can easily find that. All we would do is work with, we can find the mean. Add those two, divide by 2. $140 plus 160, divide that by 2, should give us 150. And then part D, 1.5 standard deviations below the mean. 1.5 standard deviations below the mean. All right, so once again, here's our mean. We go to the left, -1, to the left, -2. We see we have an 80, we see we have a 60. We're gonna do the same thing because -1.5 or 1.5 is in between these two. So add them up, divide by 2. $60 plus 80 divided by 2 will give us 70. Right, so some nice examples, and that's exactly how your homework will start off. Let's take a look at next type of examples that we'll see. How about we say that the figure illustrates a normal distribution for the prices paid for a particular model of a new car. The mean is 17,000. And the standard deviation is 500. Right, so let's take a look here. This is what our normal distribution curve looks like. All right, our mean, 17,000. Once again, we have 3 of them to the right. 1, 2, 3. 3 of them to the left. 1, 2, 3. Mean is 17,000. Standard deviation is 500, which means we add 500 every time. Right, so 17,500. Add it again. 18,000. Add it again. 18,500. All right, once again, it's always plus 500, plus 500, plus 500. And now we subtract 500, 16,500, subtract 500, 16,000, subtract 500. And what do we get here? 15,500. So just like the previous example, we start off the same way. What we want to do here is we want to use the 68, 95, 99.7 rule to find percentages let's go with A between 16,500 and 17,500. Example B. Between 17,000 and 18,000. C. Between 15,500 and 17,500. D. Less than 16,000. E. More than 17,500. So we want to find percentages, and we want to use this 68, 95, 99.7 rule. So take a look here. Right, this is where we started talking about our percentages, right, to the 68, 95, 99.7 rule. So you want to have these percentages memorized because they're always going to be the same percentages anytime we're using the 68, 95, 99.7 rule. So I want these percentages memorized, and we're just going to put them in our graph there. So 0.5, 2.35, 13.5, 34. See the same numbers going that way, right? So we just have to memorize them this way, and then we put them in again like that on our graph. So this is 0.15. This is 2.35. What else do we have? 13.5 and 34. 13.5 and then 34, and then we just repeat them again. Okay, now we can answer any question that we want. It says between 16,500 and 17,500. So here's my 16,500. Here's my 17,500. Add those numbers. $34 plus 34, 68%. Very nice example. Okay, now we have 17,000 and 18,000. Once again, between. Here's 17,000. Here's 18,000. Between are those numbers. So we're just going to add those. $34 plus 13.5. That gives us a what? A 47.5. Let me put that up here. Hold on. Okay. Between 15,500 and 17,500. Here's your 15,500. is your 17,500. Between would be these numbers. So all we're going to do is add those. All right, so 2.35 plus 13.5 plus 34 plus 34. And what does that give us? So we got 2.35 plus 13.5 plus 34 plus 34. That should give us an 83.85%, and the percent will be on the outside there. Less than 16,000. Here's 16,000. Less are the numbers to the left, so we'd add those. So you got 0.15 plus 2.35, and what does that give you? So 0.15 plus 2.35. You should be able to add those up to get a 2.50 or 2.5%. And then we have more than 17,500. Here's your 17,500. More is to the right, so we would add those numbers. All right, so let's take a look here. That is a 13.5 plus a 2.35 plus a 0.15. So we add those numbers, and that gives us a 16%. So some nice examples on how to work with this 68, 95, 99.7 rule.